Hello everyone, this is JC Mayuri Marata, your pre-service teacher. For today, we will be talking about Lesson 4, the Nano World. Nano World of Science and Technology is of great interest of government, industries, and academia. So the prefix nano denotes sizes of the order of 1 billionth of a meter. So, nanostructure science and technology is a broad and interdisciplinary area of research and development activity that has been growing explosively worldwide. So, in the past few years, it has the potential for revolutionizing the way in which materials and products are created and the range and nature of functionalities that can be accessed. So the history of nanotechnology traces the development of the concepts and experimental work falling under broad category of nanotechnology. The emergence of nanotechnology in the 1980s was caused by the convergence of experimental advances such as the invention of the scanning tunneling microscope in 1981 and the discovery of Fuller's in 1985 with the elucidation and popularization of a conceptual framework for the goals of nanotechnology. So, nanotechnology has been there for a longer period of time. So, the two terms often used in the literature with reference to the world of nanomaterials are nanoscience and nanotechnology. So, nanomaterials denote divided matter. So, as Rao in 1999 said, if you take a piece of solid matter, say for example a metal, containing an Avogadro number of atoms and go on dividing it to smaller bits, you will ultimately end up with an atom of the substance. So before that, you will reach a stage of very tiny particles containing 100 to 10,000 atoms. So such particles with diameters of 1 to 50 nanometer to 10 to 500 are referred to as nanoparticles. So nanoscience refers to the scientific study of materials of nanometer size, 1 billionth of a meter. So it is a combination of development in solid state chemistry, synthetic chemistry, molecular biology, solid-state physics and engineering, and scanning tunneling microscopy. While nanotechnology refers to various technologies produce materials of extra high precision and dimensions on the scale of 1 billionth of a meter. This person, Norio Taniguchi of Tokyo Science University, is credited with coining the term nanotechnology in 1974. Nanotechnology implies the ability to generate and utilize structures and components and devices with a size range from about 0.1 nanometer or atomic and molecular scale to about 100 nanometer or larger in some situations. So by control at atomic, molecular, and macromolecular levels. So there are significant persons who have contributed to the growth and study of the nano world. So first we have Richard Feynman. So the retroactive discovery of Feynman's plenty of room gave nanotechnology a package history that provided an early date of December 1959 plus a connection to the charisma and genius of Richard Feynman and Feynman's stature as a Nobel laureate and as an iconic figure in the 20th century. Science surely helped advocate nanotechnology and provided a valuable intellectual link to the past. Next, we have Eric Dexler. So his paper on the nanosystems, molecular machinery, manufacturing, and computation received the Association of American Publisher Award for the Best Computer Science Book of 1992. So Drexler founded the Foresight Institute in 1986 with the mission of preparing for nanotechnology. So nanotechnology and nanoscience got a boost in the early 1980s with two major developments. These include the birth of cluster science and the invention of the scanning tunneling microscope or STM. So these developments led to the discovery of Fuller's in 1985 and the structural assignment of carbon nanotubes a few years later. The scanning tunneling microscope, an instrument for imaging surfaces at the atomic level, was developed in 1981 by Gerd Binnig and Heinrich Rotter at IBM Zurich Research Laboratory in 1986. So Binnig, Calvin Quate, and Christoph Gerber invented the first atomic force microscope in 1986. So the first commercially available atomic force microscope was introduced in 1988. So, and IBM research Don Eigler was the first to manipulate atoms using a scanning tunneling microscope in 1989. He used 35 xenon atoms to spell out the IBM logo. So he shared the 2010 Kavli Prize in Nanoscience for this work. So when was the initial commercial application of nanoscience or nanotechnology? So in the early 2000s saw the beginning of the use of nanotechnology in commercial products, although most applications are limited to the bulk use of passive nanomaterials. Examples include titanium dioxide and zinc oxide nanoparticles in food packaging, clothing, and disinfectant, and household appliances such as silver nano or carbon nanotubes for stain-resistant textiles, and cerium oxide as a fuel catalyst. So as of March 10, 2011, the Project on Emerging Nanotechnologies estimated that over 1,300 manufacturer-identified nanotech products are publicly available, with new ones hitting the market at a pace of 3 to 4 per week. So that was when the commercial applications, is initiated. Now, what are the uses of nanoscience or the nanotechnology? So, the Joint Center of Bioethics in Canada ranked potential uses of nanosciences and nanotechnologies with respect to the development. So, the top 10 uses follows, according to BBC News in 2005, is energy production, conservation, and storage. Next is enhancement of agricultural and productivity, treatment and remediation of water, screening and diagnosing disease, systems for drug delivery, processing and storing food, controlling air pollution, construction, monitoring health, and detecting and controlling pests. So these are the potential uses of nanotechnology or nanosciences. To sum it up, the nano world is perhaps the fastest growing world in the 21st century. Global competitions among nations in nanotechnology research, development, and marketing is on the rise. So advantages of nanotechnology towards improving the quality of life are many and are felt by humankind. Whether the nano world holds any solutions for problems faced by science education is a critical question which must be addressed in its entirety. However, disadvantages of nanotechnology, especially related to human health and the environment, are only beginning to surface, raising serious concerns. Now, systematic exploration, characterization, organization, and regulation of the nano world are warranted to make the best use of nanoscience and nanotechnology. The nano world will continue to influence science and technology. So that would be all for today. Thank you for watching.